We'll start to add materials now. Before we do, I'm going to turn off the display flags of the edges and the ground, as we'll start to work on the rocks initially. Turning off the display flag means I won't have to worry about needlessly re-rendering them. Next I'll come into the material palette and select the Mantra surface. This is a generic shader that holds most of the common parameters and is a good place to start when you're developing your own look. I should be able to drag and drop Mantra surface onto the rocks. However, there's a bug in the current version that prevents that some of the time. You may find that it works for you sometimes, and other times it won't work for you. So a safer way to do that is to click the Load Selected Gallery entry into the scene. This arrow will basically pull this over and put it into the gallery. Unfortunately, there's another bug that prevents you from renaming it here because it keeps the previously selected node selected and adds the current node to the selection. So now I get the camera and Mantra surface both selected. I should be able to rename up here, but I can't. Fortunately, it's easy to deal with. I'll just go back to the shop network, and if I click on Mantra surface, that forces it to be the only node selected, and now I can rename it here or in the network, whichever you prefer. I'll rename it up here and call it Rocks. Now to apply this, like I was saying, you can sometimes drag and drop it, so I'll try it right now. I'll just drag it over here and drop it onto the rocks. And in this case I think it worked. However, in the case where it doesn't work, you can go back to the object level, select the object that you want to apply it to, go to Material, and you can click the Browse Operator Chooser, and you can browse through the network and select Rocks directly and click Accept, and that does the same thing as drag and dropping. Drag and drop simply types that in for you. So use whichever one works best for you, and hopefully that will be a bug that they can squash in a later version of Houdini 11. Now we'll adjust the parameters of the rock material while watching it interactively re-render. So we'll come over to the render view. If you already have a Mantra IPR driver here, you can select it. If you don't, simply select the Cam 1 that we added earlier and click Render to force it to re-render. It will automatically add a Mantra IPR for you. And you should see the rocks render quite quickly and then progressively get more and more refined with the anti-aliasing. I'm going to hold down Shift and draw a box just on the middle rocks here, and you'll see that these ones now render much faster. We'll go over to the shop network, click on rocks, and now we can interactively adjust the parameters on these rocks to get them to look more rock-like. First I'm going to go to Surface, and you'll notice that Use Point Color is turned on. You'll want to have that turned on, otherwise it won't pick up the random colors that we applied earlier using the copy SOP. Just to illustrate this, if I turn this off, notice that the rocks now just turn white, and I can use base color to set them to a uniform color, but it is uniform. So I want point color to be turned on, otherwise it will not be quite as interesting. I'm going to turn diffuse down slightly so that it has less diffuse reflectivity. I'm also going to turn off the reflection of lights, or the specular highlight, by going to Reflect and turning off Reflect Lights. Under Displacement, under Noise, I'm going to turn on Enable Noise, and what this will do is add a true displacement to all of the rocks. So now all of the rocks have additional details added to them, and it's truly displacing the micropolygons in this case. I can turn off true displacement, and effectively now I have a bump map, which looks alright at a distance, but doesn't break up the edge. It also doesn't catch shadows correctly. So whenever possible, I like to use true displacements. In Mantra there is something of a penalty for using displacements, but the penalty is not as heavy as some other renderers. So if you can use true displacements, you'll find that generally speaking, they'll look better than just a bump map. Naturally, you would play around with this until you got values that you liked. However, for this tutorial, I'll just enter what I am using, and if you prefer to use different numbers, please of course feel free. I'm using a frequency of 9, so just a slightly lower frequency. I'm using the sparse convolution noise, but I've turned up the roughness to 0.6, and I've turned up the turbulence to 8. And that just gives me more rough noise, which adds more detail to the visual appearance. I've also put my displacement up to 0.09, so that each of the rocks pushes out slightly farther than the default of 0.05. You'll note that the interactive preview render has noticeable pauses whenever you update parameters with displacement, especially when you have true displacements turned on. That's because true displacement is actually modifying the geometry, so it has to rebuild the geometry, then send it down to the IPR renderer. What I often do is turn off true displacements, and then I can get much more interactive adjustments. So for example, if I want to see what the frequency looks like lower, I can turn that down and it will re-render almost immediately. I'm getting a pretty good idea of what it will look like using the non-true displaced bump appearance. When I get to something that I think I like, I can turn true displacements back on. I'll have to wait a second for it to recalculate the geometry, and then it will re-render with the true displacements on. I find this a useful workflow because I'm quite impatient and don't like to wait for anything. The more patient may decide that they just want to wait for it. Also, this laptop is quite slow, so on a more modern machine you may not notice that pause. So I'm going to turn back up to 999, my frequency, and for now I'm going to leave the rocks as they are. Next, we'll apply a very similar shader to the edges of the rocks. Please note that when I say shader, I'm using it interchangeably with the word material. This is actually a little bit wrong, but it's a pretty common thing for most Houdini users to say. A shader is actually a single unit that generates a look on the object. So whatever adjusts the color and the reflectivity and refraction, that's considered one shader. The displacement is a different shader. In Houdini, those are combined into a single unit called a material. I will make every effort to call them materials. If you hear me say shader, I'm somewhat incorrectly calling a material a shader, which is wrong, and I apologize for that, but old habits die hard sometimes. So I'm going to take this rock material, Control C, Control V, and rename this to rock edges. I could apply the rocks material to the edges as well, but we probably want to alter the edge material differently from the rock material, so I might as well separate that now. I'll jump back to the object level. Notice that the viewport, which is set to the render view, stays on whatever it last rendered until I make some changes. So if I turn off the display of the rocks, the render view updates with nothing. If I turn on the display of the edges, now I just get the edges rendered in here as well. So I'll come to the edges, go to Material, and I will browse in and select Rock Edges and Accept. And now the IPR render will render the edges using the exact same material that the rocks have. Sure enough, the displacement on the edges, I think, is far too high. I'm going to turn the rocks on as well, because I do want to see the rocks and the edges together in this case. And now I'll go back to Shops, go to Rock Edges, and I'm going to take the displacement scale down to 0.03 just for the edges, and we'll see what that looks like. I think that looks a lot better. The edges are more obviously not huge inflated things around the rock. And then we'll do the same thing for the ground. So I'll take Rock Edges, Control C, Control V. I'll rename that to be Ground. And then back at the object level, I'll select the ground, go to Material. For some reason it has the rocks shader already on it. I'll select Ground and Accept, and then I'll turn on the display of the ground as well. And this will show us the rocks, the edges, and the ground all rendering together, and is starting to look much more interesting. So to see the entire render in the IPR, I can simply Shift and S to clear this window. So now I have my ground, my rocks, and the rock edges rendering in the IPR window. Next up, we'll add a bit of fog to make this look more interesting. I'm just going to resize my pane here so that I can see the nodes a little bit better. Zoom out slightly. Right now there is no shelf tool for adding fog. Fortunately, it's quite straightforward to do. In the network view here, I'm going to type tab, going to go to render and bring in an atmosphere object. Nothing actually changes because we haven't applied the material for the fog yet. So if I go back to the shop editor or shader editor, type tab here, go to atmosphere, there are a number of different fog materials. Lit fog is very realistic, but it's also extremely slow as it's ray tracing all of the fog at all depths. A better option is Z-depth fog. This is much cheaper, it's not as accurate, but in many cases it's good enough. So I'll bring in Z-depth fog, go back to the object editor, and go in and select that. Now I have fog in the background, but it's not really coming forward, so we're not really seeing the effect of it on the ground. A handy interface tip, if you want to get to the interface for any referenced operator, so in this case the material, I can either click the arrow, which will jump me there, or I can control left mouse button on that, which is what I'm going to do. So control left mouse button, this pops up a floating window, which is the interface to this shader. Now I want to go in and adjust the clipping planes. If I set it down to 0.5, that's obviously too close to the camera. So I'm going to middle click and interactively adjust this until the fog goes just to the edge of my grid. So it's just hiding the edge there. Near clipping I can also adjust, and that will push out the fog so you'll have a very narrow band of fog. Normally though, you want to leave this quite close to the camera. So a near clipping plane of 0.4 and a far clipping plane of 9 seems to work well. We'll also adjust the color, so I'm going to make it a very slightly brown fog. And I played with this and I found that a value in RGB of 0.5, 0.5, and 0.41 gave me just a hint of kind of a sickly, polluted yellow in the fog. You can of course adjust the saturation upwards if you want a lot of pollution. For myself, I'm going to leave it at 0.41. And then we'll close that. And now we've added some very basic fog to our scene. Before we carry on with some additional tricks that we can use here, I'm going to make a few optimizations to the scene. One thing you'll notice is that the edges take quite a long time to calculate in particular, although rocks can also take a fairly long time depending on how many rocks you have in your scene. So I'm going to stop the render view, go back to my scene view, and I want to change it so that what I see in the viewport is simplified compared to what is actually rendered. This is a very common way of working in Houdini, where you set up essentially live proxy geometry, and that proxy geometry is what gets displayed, but only when you render does it actually generate all of the real geometry that the renderer uses. So first of all, if we look in the ground, just double clicking on that, you'll see that we have an object merge that brings in the ground plane. The ground isn't very expensive, so I'm going to leave the ground alone. I'm not going to do anything with it. So the display and render flags, the blue display flag and the purple render flag, and they're on top of each other, so you've got this purple ring indicating where the rendering is happening. They'll just stay on the same node. If I click on ground, I can jump directly into another object as well. So I'm going to click on edges, and you'll see that the object merge here is also bringing in the geometry that will be rendered. This is one of the ones I'm going to change. I'm going to make it so that the edges only show up in the renderer and don't show up in the viewport. To do this, I'll add a null operator. Just type nu, get a null. I'll label this one display, and the object merge I'll rename to be render. And if I hold my mouse over the display flag, it'll tell me that if I click, it will set both the display and render flags. So if I click here on the display flag for the null, it moves both of them there. I can hover my mouse again, and the tooltip will tell me that I can control click to set only the render flag and alt to set only the display flag. So I'll control click, and that will move the render flag over to the render node. The display will stay on this null SOP. And if I middle click on the display, you can see there are no points or primitives in here. So nothing gets shown in the viewport. If I middle click on render, this has the polygons in it that will actually render. So if I go back to the object level, now the edges are displayed, but they're not actually seen in the viewport because the null SOP, or the null operator, is what's actually being viewed and doesn't actually have any geometry in it. I can double check that this is working by right clicking and launching a Mantra IPR right here from the viewport. And sure enough, the edges are rendering correctly. So I'll just close that out. For the rocks, we're going to do a little bit more work. I want to be able to see the rocks in the viewport, but I don't want to see the unique displaced ones. I just want to see a sphere of the correct size at each position. For that, we have to go back into our geometry setup object. And remember that we've got the copy rocks right here that's creating the sphere size, but also doing the fractal and the ramp lookup of the color. All of that combined, as it copies each of those rocks individually, can take a little bit of time. What we can do is create a smaller proxy network. So I'll bring in a copy operator and wire that to the scatter. So the template or write input is wired to the scatter. But for the base rock, I'm going to bring in another sphere operator, pipe that into the copy, and if I put the display flag on there, that will copy one sphere, and I can scale this down. That will copy one sphere to each point, and that happens very, very quickly because each of them is the same. They're not being uniquely copied. I can then take the sphere size parameter, I'll just take this expression, Control C, come over here to the stamp, Control V, type in sphere size. So I'm making another stamp parameter here, and I'm going to call this operator copy rocks proxy. And then in the base rock, I've got my stamp expression here that looks at copy rocks for sphere size. So I'll just Control C, copy that over to this one, but instead of it looking at copy rocks, I'm going to have it look at copy rocks proxy. And then I can Control C, tab, Control V, tab, Control V, and then when I turn on stamp inputs, you'll see that this happens extremely quickly as well because I'm only stamping one value. And I made a typo there. That was a good example actually of Houdini warning you when you make a mistake. So I had made a typo there where I had accidentally typed in copy group, and the yellow flag came up. So if I'll deliberately make an error here. I'll just type error. Notice that I now get a warning on the node. So this yellow and black indicator there is showing me that Houdini's trying to warn me about something. If I middle click on that, it says bad parameter reference, copy rocks error, and it tells me which parameter that's in. So in the sphere node, in the rad parameter, radius parameter, I've made a typo. So I'll just remove that. The interesting thing is Houdini still works in this particular case. In other cases, it would just not work, and you wouldn't get the stamping the way that you wanted it to. So I guess I was a little bit lucky that this actually worked with that typo in there. But Houdini does try hard to warn you whenever there's a typo or a mistake. So I'm now going to bring in another null operator, wire that into the copy rocks proxy, and I'm going to name this out rocks proxy. I'll jump directly into my rocks object from here. I'll call this one render because this is object merging in out underscore rocks. Control C, Control V. Name this one display. And I'll browse in the object merge for out rocks proxy, which brings in the spheres. Don't forget to put back the render flag here. So let's pretend that I forgot to do that. If I go back up to the object level here and do a mantra IPR, what's interesting is I still get some pretty unique rocks because the displacement shader is still modifying the base geometry and displacing out and giving me an interesting look. But I've lost all of my colors, and also I've lost the unique shape of the rock before the displacement was put on. So inside the rocks here, I want to make sure that I put the render flag using control click on the correct node, and then just to double check, I'll render that one more time. And now I can compare that previous frame with the actual frame. And what's interesting is that some of the rocks don't actually change very much, and other of the rocks change quite a bit. So in this case, you might be able to get away with just a displacement shader, but you still want that unique color on there to vary it up. Let's go ahead and add some lighting to this. Right now the light that's been added is from the camera. So it's called a headlight, and that's in there by default so that whenever you render you actually see something. Generally speaking, you don't want to just use a headlight unless you're doing projection effects where the lighting actually doesn't really matter and you're taking the lighting from the background plate. The easiest way to add a light, make sure that camera lock is turned off, because if camera lock is turned on, you will accidentally move the camera you're looking through. So we'll turn that off, and then I'm going to space, orbit, and dolly out slightly. Look at my field from over here, and I'm going to turn on ghost other objects so that I can see the entire field and also see the camera. If I do this at the object level or at the SOP level, it doesn't really matter actually, so I can also come back to the object level and I don't need to do that. So I basically want to have an area light that is shining in from roughly 90 degrees off the camera. Again, this is an aesthetic decision and you can adjust it later. So I'm going to, once I've got this view set up, control click on area light, and that will drop an area light in that's pre-configured to be set up so that it is viewing where your view was and positioned in space. So now if I space and dolly out, you'll see that my area light is up here. We have a single area light, and my camera is right about there. So if I look through camera 1, and let's go back to the render view for this next part. So I'll click on render, which will render out through the mantra IPR. So obviously our lighting is quite a bit different now. Raking in from the right side, giving us a very high contrast look. So all of our shadows are completely black. This is where displacement really shines. You can see that the displaced ground is also casting little shadows from the bumps. So you get a very accurate look when you use displacement, as opposed to a bump or normal map, because bump and normal maps have no real geometry to cast shadows from. I'm going to shift click just a narrow band down the middle here so that I can start to play with the lighting a little bit more interactively. And again, on a faster, more modern computer, you can probably have a wider area that you work with. So the scene's a little bit dim. I'm going to turn up my light intensity to 3. There are some very powerful tools in the render viewport that allow you to analyze the brightness and color as it renders. Down at the bottom here, we've got a little stow bar that if we open gives us some color correct controls. So we can use our red, green, and blue. We can look at the alpha, which is just solid, of course. There's also a brightness control. If you middle click on that, you can brighten the entire scene up. This is not adjusting the render. This is only adjusting what's seen in the viewport. And you just click on the little icon next to it to reset it back to its default. On the far right is an adapt to full pixel range button. And what this will do is analyze the render and then adjust the controls to make sure everything fits between 0 and 1. So if I click on this, notice that it had to increase the brightness to make the brightest pixel hit 1. That means that I can probably go higher in my light intensity without it hitting a value of 1. Mantra always renders a high dynamic range image. You never have to worry about going above 1 as long as you save it to a file format like EXR or Houdini's PIC format that support floating point HDR images. It's not a big deal if you render something that's higher than 1. Other formats like JPEG or Targa will clip at 1, and you definitely don't want to have your values above 1 in that case. I'll just reset this. Another way to look at this is to use the histogram button. So up at the top here, in this little stow bar, there are some color controls, and one of them here allows you to change to histogram. In this little stow bar, so this is what it will look like initially, is this little stow bar. If you click on the histogram button, this will give you a histogram that gives you an idea of how many pixels are at what brightness. And you'll notice that there aren't any up here at 1. As always, I suggest you take a look at the help for more details on this feature. For now, I'll just leave the light intensity at 3. That's fine. The next thing we will do is change the rendering algorithm. The default in Houdini is micropolygon. This is a good compromise between speed and quality, especially when you turn on motion blur and depth of field and effects like that. Micropolygon is very effective at rendering these things. If you don't have any ray tracing turned on, micropolygon is also extremely memory efficient and can render very large scenes of data. A different algorithm is physically based rendering. This uses ray tracing, but also includes very good support for area lights and also diffuse bounces. I'm going to click on the output driver parameters here, go to Properties, Render, change the well, let's move this out of the way for a second. Before I change the rendering engine, I'm going to take a snapshot so that I can see what the before and after are for the micropolygon rendering versus physically based. So I'm going to change snap 1 to be micro poly, and then click the snap camera button. Then I'll change the rendering engine over to physically based rendering. It will re-render and look pretty similar to what I had before. And if I scrub the bar here to take a look at the differences, the difference barely noticeable. One reason for that is under the shading tab of my render controls, you'll see the diffuse limit is set to 0. Nobody understands why this is the default, since when you turn on physically based rendering, the first thing you expect to see is some global illumination happening. So we'll need to turn up the diffuse limit. I like a diffuse limit of 2 to start with, even though a diffuse limit of 3 is probably more realistic in the long term. So I'll set this to 2 and wait for it to re-render once again. And now when I scrub back and forth, I can see in the shadow area, in particular, that some bounces are coming in there. If I turn up the brightness, it really highlights that. So if you look in the shadow area, When it's set to micropoly, there are no bounces in there, and when it's set to physically based, I'm starting to get some bounces in that area. If I want to see this refine faster, I can draw a smaller box just in this area that I'm testing with. So there's the micropoly and there's the physically based. To see more of the samples in there, I need to come to sampling, and I'll set my pixel samples up from 3 to 5. What this will do is cause it to send more samples into that area, and I'll get a smoother.
If I change this back up to 0.5,
let me close the rendering interface here. One of the things that is affecting how much bounce light I get in here is the diffuse setting on my shaders. So if I jump back into shops and I take a look at ground, you'll see the diffuse intensity is 0.357. And I do the same for the rocks. I'll go to surface, diffuse, change that back to 0.5. When it re-renders, of course the image is now brighter because more diffuse light is also being sent to the camera. So I'll reset my brightness parameter here and then dial it back up until I can see in the shadows a little bit better. More diffuse bounces are also going into the shadow area of the rock. So if I draw out my box across several of the rocks that have shadow area, with physically based rendering turned on, I should see some light being scattered into that shadow area, and in fact I am. Please note that if we take a look at the render output driver here, the number of samples increases the number of times that it refines the image. I can turn this actually down to 1 by 1, and it will refine the image extremely quickly, but the final image that it gets to will be very noisy, and it will be a little bit hard to tell what is actually a problem and what is just some rays of light that have bounced into the shadows. So for physically based rendering, 2 by 2 is kind of the minimum you want to go to start to take a look at these noise areas in here. You can also turn down the noise level, so instead of 0.05, if I set that to 0.02, what that will do is cause more rays to be sent out in the dark areas. So these controls, again, best to read up on the documentation, but these controls are a balance of pixel samples and the min and max ray samples plus the noise level parameter, which will eventually get you to your final image. Some people are tempted to crank the max ray samples up, so if I set this to 64, for example, see what that will look like. This will be a little bit slower, and it will fire out a lot more rays wherever it finds noisy areas. In actual fact, though, it's better to leave this down at something like 9 and turn the pixel samples up to even as high as 8 by 8 to get a final quality render. So I'm just going to draw a box around this rock over here just because it'll render faster and we can see the result faster. So it's going to refine and refine and refine, and eventually all of the noise will go away. And I'll just turn up my brightness here, and you can really see into the shadows. There are some bounces happening there. Now if I set my brightness back to 1, it's still pretty subtle with those bounces in there. If I set my diffuse limit to 3, it doesn't make a huge difference. If I set my diffuse limit to 1, it will be less noisy because it only has to do 1 bounce. It will also render a little bit faster, and if I crank it up, I still see that it's being filled in there. So a diffuse limit of 1 or maybe 2 is probably the way to go here. So I'll set this to 2. By using physically based rendering, we also open up some other interesting possibilities, such as using geometry as lights. So under sampling, I'm going to set my pixel samples back down to 2 by 2, and I'm also going to reset my noise level to default. And I just do that by right-clicking, and it's kind of going off the screen here as I capture, but if I right-click on this, there's a revert to defaults parameter. If you select that, it will bounce it back to whatever the default value was. So this will refine faster. It'll be much noisier, but it'll also be a lot quicker to work with interactively. And I'll set my brightness back down to 1 and close out my Mantra IPR window here. I'm going to click the stop button on the render view so it doesn't accidentally re-render while I'm working setting up the next section. Go back to my scene view here. I want to now create geometry lights. Geometry lights can be a little slow to render compared to an area light or a point light, but they can also offer some effects that are quite unique. So we'll take a look at that right now. I'm going to go back to the object level, select my rocks, and then click on geometry light. It brings in a geolight. It also turns off the display of the rocks. That's not really what I want, so I'm going to turn the display of the rocks back on so that I see those render as well. And now I'm going to come back to my render view, click render to restart the rendering. I'm also Shift S to clear that render box so I can see the entire field being rendered. So I don't see very much because the geolight isn't very strong by default. If I turn up the light intensity to 10,000, then I will start to see my landscape be illuminated by the rocks. So we need to tune the geolight settings a little bit. I'm going to again just draw a box in the center here to see this a little bit more interactively. The first thing I'm going to do is drag down, go to attenuation options, and set this to be physically correct. When I do that, my 10,000 now is far too bright. So I'll set this back to 100, which starts to look a little bit more like interesting glowing rocks. One thing to note is that the rocks are picking up the color from the points, so each rock's light is also unique. You notice that the lights and the glow are different for every one of the rocks. If I set this back down to a light intensity of 1, don't see much, but I can interactively start to pull this up until I see the rocks starting to glow. So I'm going to leave it at a value of 40 for now. And of course we can adjust this later. Now if I wanted the rocks to not pick up the color of the points, I would need to extract the rocks into their own object. And that's what I'll do right now. So I'm going to pause this render, go back to scene view here, and I'm going to type tab and bring in a new geometry object, and I'm going to call this rocks extracted. Jump inside, delete the file, bring in an object merge. I'm going to transform into this object, drag down, and I'm going to bring in the render for the rocks. So I go to the rocks object and bring in the render SOP, because remember they're different now. The render is the actual rock that's been deformed. The display is just the sphere. I'll bring that in. And if you've got your Ghost Other Objects turned on, notice that I'm seeing the render geometry compared to the display geometry. And the display geometry, each of the spheres, is basically larger than the displaced underlying geometry, the geometry that we ran through the fractal noise. If I middle click on this, remember that we've got a primitive attribute called CD. And that's what the geometry light is picking up, is that primitive attribute called CD. I'm going to bring in an attribute, and under primitive, delete the CD attribute. And when I middle click on this, notice that the CD attribute is now gone. So the color of that render geometry in this object has been deleted. I'm going to rename this to be delete prim CD, just so I know what it does. And make sure the render and display flags are turned on here, because that also affects the geometry light. In the geolight, under the area light options, because this is effectively an area light, if I drag down to the bottom, this is the geometry object that it's rendering. So I'm going to click this, and now I'm going to select rocks extracted as the render object, and I'm going to turn off the display of rocks extracted. Now we'll go back to our render view, unpause it, and it's fairly subtle, but now the lights are not picking up the color of the rocks underneath. So I'm going to pause this again. Another interesting effect that we can do by going back into rocks extracted, instead of merging in the render, we can merge in the display, which is the spheres. This is giving me a warning saying that there's no match for CD because those spheres don't have a CD attribute. Now there's no harm in leaving it the way it is. This is just a warning. It doesn't actually stop it from working. So it tries to delete CD, but it's not there, so it just says, okay, I'm going to tell you about that, but then I'm going to carry on. I'm going to put a primitive SOP at the end here, turn on the display and render flags, turn on do transformation, and set the scale, just interactively middle mouse on here, to scale the spheres down. Now, the reason that they kind of disappear when you go below 0 is because I've got ghost other objects turned on. So I'm going to set that to hide other objects. And now I can interactively see each of those spheres being shrunk down. I should point out that the primitive SOP applies the scale to each primitive. And remember that we copied a primitive sphere on. If you have changed the primitive sphere to be a polygon sphere, then this little trick won't work, because it will try to scale each of the polygons on each of the spheres down, and it will do that around its centroid. That will cause some strange effects. So this little trick where I'm scaling the spheres down at this level only works if those are primitive spheres. And what I really want to do is see what the rocks look like displaced compared to my scaled spheres. So if I go into the rocks object, I'm going to temporarily put the display flag onto the render. And if I go back into rocks extracted, now if I take a look at ghost other objects and I scale this interactively, what I want to do is shrink down those spheres so that they are partially inside and partially outside the rock that has had the fractal noise applied to it. And then I'll go back to my rocks object and alt-click to put the display back on the spheres so I don't forget. And now if I take a look at the render, I basically have each of the lights coming from the sphere that's inside the rock, and part of the sphere is hidden by the displaced rock and part of it is exposed. So instead of having the entire rock glow, I have sections of the rock glowing. In my opinion, this is a lot more interesting visually. We can take a look at some of the other areas here, and you can see that the rocks have glowing bits inside themselves that are casting light out of them. So I personally find this a more visually interesting result, where instead of the entire rock glowing, it's almost like there's part of the rock that's exposed has a glow to it that's lighting up the environment around it. We'll conclude this tutorial by doing a flyover of our field. So I'll click stop on my render view, go back to scene view, and what I like to do is have multiple cameras in my scene so that I don't accidentally move the animated camera when I don't want to. So cam 1 is the default camera that all of the ROPs will pick up. I can rename this to be test cam, for example, and then bring in a new camera that I can fly over the scene. If I go up to test cam, I can create a new camera, and the new camera will automatically pick up the view that I'm looking at. But let's say, for example, that I have come back out here, controlled clicked on my shelf, which will create a camera up here, but now I want to copy the view from test cam to cam 1. If I look through test cam, I can say save view, and it asks me what target camera to save it to, and I'll say cam 1 and click accept. And now test cam and cam 1 have the same view. It just copies the transform of test cam over to cam 1. So now I'll take cam 1, and in the viewport, make sure that I'm in show handle mode. Remember, hit enter for that. If I type K, just the letter K, that will set keyframes on all of the important parameters on the camera. And then I can go forward to, let's say, frame 120, and I can use the handle. I'm just going to do a very simple move across the field. Something like that. And then I'll type K again to commit those keyframes. And now I have a very crude, simple camera move across the field. I want to render a sequence of this just to see what it's going to look like. I want it to render fairly quickly. So I'm going to create another ROP, go to Render, Create Render Node. I'm using physically based rendering, so I'll use Mantra PBR to create a new node. And instead of Mantra IPR, I'll rename this one Mantra Low Seek. Low_seek. So that stands for low quality sequence. I'll set the frame range to be 1 to 120. And in the properties, under sampling, I'm going to set the pixel samples to 2 by 2. I'm also going to set the max ray samples to 2. Under shading, make sure my diffuse limit's set to 2. And under dicing, I'm going to set the ray shading quality to 0.5. That will reduce the quality of the ray tracing, but will give you increased speed. So when you're doing tests, this is a useful parameter to turn down just to get fast feedback. Also, I don't want to render the whole scene. I want to render a slice of the scene, again for speed of interaction. So at the object level, I've got my cam 1 selected. I'm going to drag in the crop so that only this slice down the middle renders. And we'll see why I'm doing this in a moment. The crop handle by default blacks out the areas that it won't render, and it appears there's not much you can do about that. This camera crop is very useful, but it's also a little bit dangerous. If you accidentally leave this turned on and you send it to render, you'll be very disappointed in the morning when only a part of your scene got rendered. So I'm going to rename this to Cam 1 Cropped, and I'm going to copy and paste it. And Cam 1 itself, I'll make sure I'm looking through Cam 1, type enter to get the handles for that. Just select that. I'll turn the crop off for Cam 1. You have to click on the node in the network before you will see the handle properly. You can't just select it up at the top here. Looks like another little bug. So now if I go to the output driver, Mantra Low Sequence, under main, I need to make sure that I've selected the correct camera here. So Cam 1 Cropped is the one I want to render for my test. Later, Cam 1 without the crop is the one that I want to write out to disk, or if you're at a studio, send to the render farm, or so forth. After adjusting my properties and setting up the crop, I can now click Render. Before I do that though, this is a great time to save. So I'm going to do a file Save As, and I'll save this as number 7. My version 6 in progress was just me, while I do the tutorial, saving every now and again just to make sure I could go back when I paused or took a break from the video. So in your case, you should go right from 6 to 7, or whatever naming or numbering convention you've chosen to use. So now I'll click Render, and we'll see what it looks like. Okay, so I'm going to interrupt that here and press play, turn on real time, and oh, there's a problem. As the camera moves, the surfaces boil. Now, in certain cases you might think that's cool. Most of the time you want the noise to stick and not stick to the camera, you want it to stick to the objects. That's why we do test renders. As it turns out, there's a known bug in the Mantra surface node that causes the noise to stick to the world space position, not the object space position. Fortunately, it's very easily corrected, and we'll take a look at how to do this now. So I'll close out this window, don't need that anymore. Jump over to the shop editor. I need to do the same adjustment in all three of these. So I'll do it in one slowly, and then I'll do it in the other two fairly quickly. While I'm doing this, I'm going to maximize this pane so that we can see everything in this network as clearly as possible. So I'll just click on the Maximize button, and then double click on Rocks. And if I zoom out, there's a potentially confusing network of nodes that defines the different parts of this material. Without getting into a material shader tutorial, which we'll do separately, the output collector brings in the different shaders, and the third input is the displacement shader. So if I trace that wire, I'll just zoom out and trace this wire. This is where the displacement is coming from. The actual noise is coming from a turb noise operator, and the position input controls what the noise sticks to. In other words, how the noise is calculated. And you can see that's hidden. If I middle click on the node, I can expose input nodes, and this will open up and show me that connected to this is global P. I can't see the parameters by default, but I can, without minimizing this, go up to the gear menu, go to Viewing Controls, and turn on Show Parameters. And the hotkey is P. And this is one that I use a lot. So if you type P, this will show or hide parameters inside of a network pane. And I personally find this very useful. So this global variables is set to output a single variable of type surface position P. Without, like I say, getting into a tutorial on making materials and shaders, surface position P is by default in world space, and world space and camera space in Mantra are the same thing. So all that means is when the camera moves, P is effectively stuck to the camera. What we can do is type tab TR and bring in a transform node, and a transform node will convert from a certain space to another space. If you're not fully following what's going on here, don't worry. What we're doing is fixing a problem that hopefully side effects themselves will fix quite soon. What I want to do is take this transform, wire the surface position into the 3D entity value, and then wire the position from the turb noise into the transformed value. Note that I'm not altering the wiring of global P that goes into the displace normal operator, because that would break things. So I'm simply fixing it right here. And I'm transforming from space current, which means whatever space this is in already, which I just mentioned is in world space, and transforming it to space object. And what that will do is make sure that P is attached to the object, not attached to the world or camera space. So simply inserting this operator without changing any of the parameters fixes this bug. What I can do now is Control C and jump directly into ground. And if I zoom out and drag down, I'll do the same thing down here. I'll middle click on the position, expose input node. I'll Control V, and notice that interestingly it wired itself automatically into global P because it knew that that's what it was wired into in the other network. Now all I have to do is wire the position into the output. And then I'll jump into rock edges, come down here, middle click on position, expose input node, Control V, and then wire position into the output. Now I've fixed this in all three of these materials. I don't have to re-hide this if I don't want to. It being hidden or not hidden doesn't actually make any difference to how the operator works. Though if you want to, you can middle click on this and say hide input nodes, and that will hide those nodes. Control Z will undo that if you don't want to do that accidentally. The other thing is you have to be very careful when you're inside of this network. You're dragging nodes around. Notice as you drag over a wire, it highlights yellow. If I let the mouse go at this point, notice that it rewired this automatically for me. In VOPs, it's extremely dangerous because this can break your shader and you will not know what the heck to do to recover other than Control Z to undo. When I'm in VOPs, I like to turn off the auto drop, and right down at the bottom here it says enable drop on wire. I like to have that turned off when I'm in VOPs so that I don't accidentally drop a node onto the wire. So with that turned off, I can't drop the node and have it auto wire for me. So I fixed all these nodes. I'll set my pane back to normal from maximize. I don't need to see the parameters in here anymore because I have a parameter pane at the top, so I can type P with my mouse down at the bottom here and turn off the floating in pane parameters. I'll go back to outputs. I should probably render another low sequence just to be safe, to make sure that it's actually working. So go ahead and do that. I'm not going to bother because I've already tested this and I know that it works properly. You should probably do this yourself, just 5 or 6 frames to make sure the noise is sticking correctly to the ground. And then I'll make another mantra node. I'll just type tab in this case, and I'm going to call this mantra final. I'm going to select the correct camera, so not the cropped camera, but the non-cropped camera. And that should be in there by default unless you renamed it to something. Set the frame range from 1 to 120. Go to Properties, and now for the output picture, IP, which is the interactive preview, I'm going to change this to be $hip. I'm going to make a new folder, call it Renders. Inside here I'm going to make a new folder and call it Final. And inside here I'm going to render out final underscore field underscore v0007 $f4 and I'm going to render pic images. If you want to load this into another compositing package, you could also do EXR. So actually I'll do EXR because that's more of an industry standard. I've just picked an arbitrary name for the file. $f4, you have to put in $capital F. You don't need the 4, but at least $capital F, because if you don't do that, you will find that your frames render over top of each other, and you'll come back in the morning after a night of rendering and you have one frame which just simply got rendered over by all the other frames. It's very disappointing when this happens, and inevitably people learning Houdini will encounter this all the time. Industry standard is to prefix and postfix the frame number with periods. So everything before the period is some name you come up with. $f4 is the frame number. The 4 simply pads it to 4 digits. So the first frame will be 0001 and so forth. And then dot and the extension. I'll click accept on that. Under render, make sure I've set it to physically based rendering. Under sample, I'm going to render this at pixel samples of 8.8. Set my min and max to 1 and 9, and I'll set the noise level down to 0.03, which is a compromise between speed and quality. And then don't forget that the default for diffuse limit is 0, so I'm going to set that to 2. My dicing I leave at 1. Remember in the mantra low sequence I set that down to 0.5 just for speed, but for a final render I want that at 1. I also like to turn on statistics, so I'm going to set the verbosity level to 1. You can actually set it all the way up to 4, and that will just spit out additional information, so actually we'll leave that at 4. And I'll turn on Alfred style progress. Alfred style progress will tell me a percentage complete on each frame. So if you're looking at this in a non-graphical interface while rendering, you can see how far along each render is. Alfred, by the way, is a render controller that Pixar manufactures. At this point, I should probably save one more time. So I'll save this as my final, version 8. And then I'll click render and off it will go and render the field at final quality. Let's take a look at those images. Under Render, Mplay, Load Disk Files. Go into my Renders Final, click on that, and click Load. There we go, flying over the fields. Now I'm having a hard time playing this back because my laptop has not very much RAM, so I'm only looking at a few frames, but for those of you who got through it, there you go. You can see there's a few little sparkles in certain areas, so you might have to turn up the sampling slightly to get rid of those sparkles. But we have quite an interesting looking field of unique rocks that glow. I hope you enjoyed this tutorial. We welcome feedback on the tutorials, so please feel free to comment on them as well. Thanks for watching.